Welcome to another version of OpenDSS-G. In this occasion, I'm going to introduce the new input interfaces included in OpenDSS-G version 4.5. For that, I'm going to talk a little bit about the history behind it. So initially in 2012, when we created DSSimp, which was the predecessor of OpenDSS-G, we added a very simple input interface in which we have a table, we have the name of the parameter, and we just added the value. It was very easy and very simplistic. But then at the end of 2015, beginning of 2016, we decided to change everything for a more sophisticated control panel, trying to emulate the front panel of a whole equipment. Of course, depending on the number of properties of an element, which can be a big number of properties in OpenDSS, in many others, as well as in many other simulation platforms, that can become overwhelming because you're going to have a large number of controls and a lot of numbers of parameters to enter, which well makes everything more complicated when you're trying to declare an element. And this year we did a change to that. We decided to go with a simple but not too simple interface in which we have a categorized list in which certain parameters are organized in terms of categories. And we have a very interesting contextual help that can be launched by right-clicking on the tree, on the property tree that we're seeing on the screen, and getting more several tools that will help you finding properties, modifying properties, copying, moving, etc. So I'm going to show you in this video how to use it and what are the advantages of this new interface. So for that, we're going to check on the environment. So the environment looks basically the same. The menus are going to be almost located in the same locations. The only big change that you're going to find is that the control elements like fuse, reclosers, switches, and relays were changed from PDE into controls to make it more consistent with the normal distribution of OpenDSS. So for showing the new interface, what I'm going to do is creating a very simplistic model. So the first step is going to be to create a bus. We're going to make them visible as well as their names, so we can identify where they are on the GUI. The first bus is going to be a source bus. We're going to create a very simple circuit. So in this case, I'm going to add a substation or service transformer, then a transformer, then line, and then a load. It's going to be three-phase, very simple. We're going to go for 4.16 kV to 480 volts. That's it. Very, very simple implementation. So for that, I'm going to create the buses for everything. So initially, we started with the substation bus. Then we're going to go with the bus for connecting secondary of the transformer. And finally, we're going to add another bus for adding load. So the transformer going from the substation to the line is going to be between buses, source bus and transformer bus. And then we're going to create another bus called load bus. And with that, we have the three reference points that we're going to use on the circuit. The reference points not necessarily have to be defined at the beginning, can be defined on the go, so no problem. Now for defining the substation, I can do it using the text menu that we have on top of the application, or we can do it using the graphical tools palette that we have floating around the environment. So this is the new interface. As you can see, we have different categories in which we have classified different properties for the element. There's another category called other. Other applies for those properties that were introduced into OpenDSS recently, but were not migrated directly into the environment. So we can update the DLL, which is the one that interfaces with OpenDSS-G, and with that we can add new properties very easily. We can look for properties just by entering the name, and the interface is going to take us to the place where the property is. As you can see, we have three columns. We have one with the name of the property, another one with a brief description, and the value. If still we understand that description is not enough, we can still ask what's this? And OpenDSS-G will bring us the explanation directly from OpenDSS on what the property is, what's the purpose of it, some extended help, and well, other information like what's the default value, etc. I can do, or we can do that for every property that we have for the element. So we will always be informed, and we don't have to go open the help window every time we need information. We just right click on the property and we can ask what's this. So now the first step is going to be to define the base voltage kV. We're going to define the base MVAs. We're going to add just a few values for the sake of the example. In this case, we have the three phase. We can see that the three-dimensional graph has changed while we are adding values. We're going to set up the per unit value in 1.01. It's something very basic. For the other parameters, we're just going to leave the defaults. Now, when I double click on bus, I can select the bus that I want to connect the element, just like in the previous version. Here I just enter the first letters of the name of the bus, and well, I can highlight to see where the bus is located. I can zoom in, etc., just to make sure that I'm connecting the element to the right place. Then I just define the way the connection is done. I can use the automatics to define to connect everything one to one, or I can just select the terminals independently and perform the connection, implement the connection that I want to implement. As you can see, since the vSource is a two-terminal element, the bus 2 is filled automatically to the default value. However, you can change that if you want to connect the vSource in series. But normally, nobody does that, so it's fine. For the sake of example, we're going to leave it connected in shunt. Now we're going to open the element manager just to verify that we have connected our vSource and again confirm where it is connected. So I'm going to open the category for the PC elements and double click on vSource. And we can see there's one over there, but it's in yellow. I don't want to see it yellow. I want to change the color by right clicking, selecting a new color. I'm going to put it red. And of course, we can also change the icon if we don't like the one we're seeing right now. So for that, I'm just going to apply that change and we can see our substation in red. Now, next, we're going to create this transformer. It's going to be a delta Y connected transformer. For transformer, the first thing is to declare the number of windings. So we're going to declare two windings, the number of phases. We're going to say it's a three-phase transformer. And we're going to enter all the other parameters. We're going to enter the connection. It's going to be del Y. The KVAs, well, in this case, enter the KVA, but now we want to enter them all at once. So we're going to go 500 kVA per winding. And the KVs is going to be 4.16 to 480 volts. We can see the values there just by double clicking on it. Also, what else? We have to define, now the buses it is connected, all the other values are going to be taken by default. So for that, I'm going to double click on buses. So what's going to happen is the first time I double click on it, I'm going to select the bus for the primary bus. Same procedure as any other with the other elements. And then if we want to enter the bus for the secondary, I'll just double click on it again. And I'm going to get the same menu. So now I'm going to connect the secondary. I'm going to see the two buses defined there. Now, what happens if I want to change the value? If I try to enter another bus for another winding, it's going to tell me, no, there's a problem because, well, you have no more windings. So I can just delete the value if I want to start over and then start again, double clicking, setting up the buses for every winding respectively. A very simple procedure. Well, and after applying the changes, we can see that that transformer is connected. Now we're going to create a new line, but before, if I want to edit the transformer, I can see all the values that I didn't populate, taking the default values assigned by OpenDSS, which is very convenient many times because, well, I just don't want to apply all those values, and well, taking some defaults will definitely help. I can copy those values to the clipboard So here in the notepad, I just did the copy, and if I paste it, it's going to give me the value as an OpenDSS declaration. But what happens if I want to copy just the value, not the whole declaration? I select just copy the value to the clipboard, and then when I paste, we can see that the value has been copied. I can copy all the properties if necessary, so I can, in case I want to create a new element, I don't have to start from scratch, which is very convenient. Well, we're going to present that, and we're going to talk about that later. Now, the next step will be to create the line. It's going to be a three-phase line. We're going to leave the name, the default name if you like, or we can modify it as we want to. Then we're going to find the number of phases, three phase. We're going to see that 3D graph is going to change according to the parameters. And we're going to use the sequence components for defining the values of the line. In this case, really small impedances for R and X. Very simple for the sake of the example. We're going to do that for positive and zero sequence. And then we just select the buses. We have, in this case, two different fields for the buses, bus 1 and bus 2. So let's go first with the first bus. We're going to connect the first one and then the other one just by double clicking on it. I can select the other bus, entering just by typing the first letter of the bus I want to connect to. So it will bring automatically the name. With that, we are ready. So now we can see the line drawn on the GUI. And finally, we're going to add the load. So for the load, yeah, we're going to just modify a little bit the name. And we're going to add some basic parameters like how it is connected, the KV, the KV 480 volts. We're going to add the KVA, 250 KVAs. We're going to add also the power factor, in this case 0.98. Number of phases is going to be three phase. Again, for example, the model, we can bring the help and it will tell us what are the different types of model that we can use. So yep, we can define the number of phases. It's telling us, hey, there's a problem. You didn't define the bus. So that's another interesting feature here. We're trying to detect all the or secure the needed values, the mandatory values before we apply them on the element. So we can now again try to edit the element and we'll be fine. So we can see now through the element manager where is the load and where is the transformer connected in the circuit. Now, since this is a new model, we have to save it before we can proceed. So I'm just going to click on save, give it a name. In this case, I have a default name called my model, and I'll go straight into the simulator. We can see that it's telling me what's the simulation mode. In configuration, I can see all the different parameters of OpenDSS, so I can modify them depending on the type of simulation I want, the elements I want to record, the features in terms of the processing I want to implement. Very simple and through graphical interfaces. So with that, I'm going to just go ahead and solve by clicking on play. And it tells me the system was solved. Now, since I don't have meters installed in my system, I'm not going to, I don't want to add a meter. How I can, I mean, we can add monitors, energy meters, etc. But in this case, I'm going to use a very interesting tool called the quick measurements. For the quick measurements, I just select the tool and create an area, select an area in which all the elements I want to measure will be included. So in this case, we can see the line, transformer, the load, etc. Every time we click in one of the elements, it will be highlighted on the GUI. Also, it will bring all the values related to it. So we can see voltages, we can see currents, we can see the powers, and we can filter by element, by type of element, if we just want to see lines, loads, etc. We also can, for example, for the load, we can see the P and Q match with the declaration that we did previously. Same for lines, transformers, and others. Among the features that the new interface offers, we have one that is very special, and is the ability of copying or replicating an existing element. In OpenDSS, that was intended to do with the property like. However, that one is not maintained anymore within OpenDSS, so we don't recommend to use it. So here, what we're going to do is we're going to create a new transformer. In this case, I'm highlighting just the V sources and the transformers that we have on one model that probably you know very well, which is the IEEE 13 bus node test. So the idea in this example is to create another transformer deriving from bus 633 that is going to mimic the one connected to bus 634, which is a step-down transformer. For that, I'm going to create the other bus, and now I'm going to create the new transformer. However, what I'm going to do is I'm going to copy the transformer that already exists and use it as the base for the new transformer. So to check what is that, I'm going to use the exploder, and we can see that there's a transformer over there. We're going to bring it here. We know the name after using the exploder, the navigator. Uh, the name is XFM, and we're going to bring it here. So we can see all the different values for this transformer. And I'm going to create a new one at the same time. So I'm going to bring that transformer. We can see that the properties are empty. So I'm going to go to the existing transformer. I'm going to right click and select copy all the property values. After that, I'm going to go back to the new one and select paste all property values. And with that, I'm going to populate all the values that I had in that were empty are going to be populated. And the only thing I need to do now is to clear the buses and do the new connection. So the new connection is going to go from 633 to the new bus I just created. Again, just double clicking on it, the other bus. We can see where it is, connect, and then apply. And with that, I've just created a new transformer with the same features. Very easy, huh?